Good morning, good afternoon, good evening, good night. Whatever time you're watching this, I hope you're doing well. I hope you're taking care of yourself. And I hope you're having enough water and good food and not troubling people around you, taking part in extracurriculars, but at the same point of time, preparing well for the examinations and not compromising your studies back in school. So I expect that you guys have your life together. Anyways, let's go ahead. We shall today begin a new chapter which is called atmosphere. A new topic, you'd say. What basically is atmosphere? Atmosphere basically means something that surrounds you. If I say it, like your parents, your friends, your family might say something like, once in a while they say things like, the atmosphere here is really not nice, the atmosphere here does not suit me. So what is it? It means the circumstances around, the surroundings around, not the circumstances, the surroundings is something that is not not compatible with the person. Either they don't like the way certain things are done, or they do not feel comfortable, or their health is deteriorating. So things like that. So that is what atmosphere basically means in terms like this. In geography also it means almost similar. Atmosphere is basically this layer of gases that surrounds the planet. It is basically formation of, you could say, one of the major reasons why living systems exist in that, in that particular planet. And it is only that our atmosphere is habitable to give us life that we are alive and we are sitting over here discussing this. Okay, so atmosphere. Let's go ahead. Atmosphere is a layer of gases surrounding a planet or celestial body. It is a layer of gases surrounding a planet or a celestial body. On Earth, it extends from the surface up to several hundred kilometers. So on Earth, it goes from the surface up to several hundred kilometers. The Earth's atmosphere is primarily composed of nitrogen, which is 78%, which is also inactive, and oxygen, which is 21%, which is very necessary for survival. It is necessary for humans to breathe, and by breathe I mean for respiration, that is for the providing energy through the food that is being eaten. When it is treated by oxygen, we get energy through which we are able to do things that we are doing, through which I'm able to teach you, through which you are able to listen to what I'm saying. So that is one reason. Another reason oxygen is important is that it's required for combustion, and we know that without fire, life is very difficult. With it's more difficult if you cannot breathe, but still, with trace amounts of other gases such as carbon dioxide and water vapor and noble gases में 0.97% is of argon. So carbon dioxide is 0.03%. Again, that's very important because green plants use carbon dioxide to provide food for themselves, to make food for themselves. So that's very necessary as well. So what did we understand? That Earth's atmosphere is primarily composed of nitrogen 78%, oxygen 21%, with trace amounts. With trace means with very minuscule, with very minute amounts. Only it can be found in traces. Traces is something that's very less. Amounts of other gases such as CO2, that is carbon dioxide, and water vapor and noble gases. So what is the purpose of atmosphere? What are the functions that it serves? So the atmosphere serves several important functions. It regulates the planet's temperature by absorbing and redistributing solar radiation. It helps maintain a habitable climate. So as I mentioned before, it provides the solar radiation that the sun gives out, the radiations that sun gives out. It maintains the temperature because it absorbs and it redistributes this radiation. So the climate that is maintained in the world is something that we can live with. It's not something that kills us. The atmosphere protects life on Earth by absorbing and scattering harmful UV radiation from the sun. The ozone layer in the stratosphere plays a vital role in filtering out much of the UV radiation. So UV radiation is harmful to skin. UV radiation can cause skin cancer. So it's advised that every time you should travel, if you go outside your house, you should always apply sunscreen on your face and on any bare part of your body, not just during when it's sunny or not just during summers, but all through the year. It's very necessary for you to do that because it helps you prevent any chances of skin cancer. Yeah, but that's like a man-made thing that we're using. We have a natural system in place for that as well. So what is the system? This is the ozone layer in the stratosphere. Now we'll study a little later what a stratosphere is. And it plays vital role in filtering out much of the UV radiation. Certain gases in the atmosphere like carbon dioxide and water vapor act as greenhouse gases, trapping some of sun's heat within the atmosphere. This creates the natural greenhouse effect, which is important for maintaining livable temperature range on Earth. So greenhouse gases are responsible for maintaining temperature on Earth, which is livable and which is again habitable. Habitable is a very correct word for it. The atmosphere is involved in weather patterns including the formation of clouds, precipitation and circulation of air masses. It plays a crucial role in Earth's climate system. So the atmosphere is also involved in weather patterns and it helps in is responsible for formation of clouds, for precipitation and for circulation of air masses. Structure. Let's study about the structure of atmosphere. This is very necessary. Please keep this in mind. So troposphere, this is the lowest layer of the atmosphere. Troposphere is the lowest layer. So see, we're beginning, if you can see it in the picture right over here in front of you, we're beginning from troposphere. Troposphere, this is the lowest layer of the atmosphere extending from the Earth's surface up to the altitude of about 7 to 20 meters of the Earth's air mass. Up to 7 to 20 kilometers. This is where weather occurs and contains most of Earth's Earth mass. Temperature generally decreases with increasing altitude in this layer. Okay, so this is the lowest layer in the atmosphere. We have 1, 2, 3, 4, 5 layers. So the lowest layer is called the troposphere and it extends from 7 to 20 kilometers. Okay, keep in mind 7 to 20 kilometers, which is around 4 to 12 miles. And this is the region when we talk about weather. See, you can see hot air balloon, you can see mountains, you can see an aeroplane flow for there. So these are the things that exist in this layer. What is the height of Mount Everest? Last time I checked, it was 8848. So that's around 8848 meters. So that's around 9 kilometers, and it keeps rising above because of the sea level. So that's like that. That is around nothing actually. That's nothing when compared to how tall the troposphere is. So moving ahead, we have stratus. Okay, yeah, it is where the weather occurs. So this is the region where we talk about weather takes place, climate and all of that. Temperature generally decreases. So as you go ahead, as you go up the altitude, the temperature falls down. Stratosphere. Above the troposphere lies the stratosphere, which extends from the top of the troposphere up to approximately 50 kilometers. So above the troposphere, there is the stratosphere. Okay, and stratosphere goes from where the troposphere ends, from there till 50 meters above. Okay, so the stratosphere contains the ozone layer. So this is where the ozone layer, which is responsible for protecting us from harmful UV rays, is, and the temperature increases with height in this layer. So as you go above, the temperature increases in this due to absorption of UV radiation by ozone. So ozone takes UV radiation, accordingly the temperature increases. Mesosphere. The mesosphere is located above the stratosphere and extends up to about 85 kilometers. So stratosphere ends, and after that 85 kilometers above, and we have the mesosphere. So this is the mesosphere in altitude. It is characterized by decreasing temperature with height. So as you go above, temperature again comes down. So troposphere, temperature comes down as you go above. Mesosphere, temperature comes down as you go above. And this is the layer where meteors burn up upon entering the Earth's atmosphere. So meteors come here in mesosphere, and that is where they burn up. This is like so powerful that it burns up, so that it like basically gets divided into parts. Okay, let's go ahead to the next layer. The next layer is the thermosphere. Thermosphere, beyond the mesosphere lies the thermosphere, which extends from about 85 kilometers up to the thermopause. So from 85 kilometers up to the thermopause, which can vary, but it is typically around 600 kilometers above Earth's surface. So just imagine 600 kilometers above Earth's surface. 600 kilometers is from that's like halfway, somewhere around Kashmir, halfway to India, somewhere around Madhya Pradesh. So that's like how far thermosphere is from the surface of the Earth. This layer experiences that if that distance, that is a horizontal distance, if that distance is turned into a vertical distance. This layer experiences high temperatures due to absorption of solar radiation, although the actual air particles are not significantly heated due to their low density. Now, as you go above, the density decreases, and hence the particles are not really heated, but this layer has a high temperature observation because of absorption of solar radiation. Exosphere. The outermost layer of the atmosphere is the exosphere. So after the thermosphere, there's the exosphere. It gradually transitions into space and contains very few air molecules. So this is where we have coming, like, there's less less contaminant. There are less amount of air molecules, and this is where we are going into space. Satellites and other human-made objects in orbit around the Earth are located within this layer. So it's in the exosphere that we have the satellites and other human-made objects. We're not talking about the moon over here. Air pressure. Definition. Air pressure, also known as atmospheric pressure, is the force exerted by the weight of the Earth's atmosphere on a given area. On a given area, the force that is experienced by the Earth and by the that is exerted by the Earth's atmosphere is known as atmospheric pressure. It is caused by the gravitational pull of the Earth on the air molecules. Units of measurement. So air pressure is typically measured using a barometer and expressed in units such as millibars, pascals, inches of mercury, or pounds per square inch. What is a low pressure area and what is a high pressure area? Okay, so pressure, we discussed what air pressure is. Low pressure, you understand, less pressure. High pressure, more pressure. Okay, now let's see what is it. A low pressure area, also known as a cyclone or a depression, is an atmospheric region where the air pressure is lower compared to the surrounding areas. So you see, these areas have high pressure, but this certain area where L is mentioned has low pressure. Okay, so what happens, also remember this, that this is known as cyclone or depression, where air pressure is lower compared to the other areas. So what happens, as it happens, this is the thing, like see, this is high, there is this thing that is attached to this another vessel, which is this much in, okay, so this is a liquid that we have. So this will flow through this until they are both on the same level, right? So that means anything moves from higher pressure area to a lower pressure area. Why? Because to maintain an equilibrium. So what happens is that the winds flow from the regions which are outside, which from the higher area regions, higher pressure area regions to the lower pressure area, and hence what happens, the wind from surroundings blows towards the center of low pressure. So center of low pressure, this is where the winds blow from. It is marked as L on the weather map, and it is characterized by rising air and converging winds. So you see the winds are converging, they are moving inside, the winds are converging. And then it's a low pressure mein kya hota hai? The temperature is high, so the winds rise up. High pressure area. A high pressure area also known as an anticyclone. So low pressure area is called a cyclone. High pressure area is called an anticyclone. Is an atmospheric region where the air pressure is higher compared to the surrounding areas. It is characterized by sinking air and diverging winds. The wind from the center of high pressure blows towards the surrounding low pressure areas. So now these are diverging winds observed. And the air sinks here because higher pressure. ठीक है, तो क्या होता है कि the higher pressure, these go out, this is a higher pressure area, so these winds go to the lower pressure area again to maintain equilibrium. ठीक है, it is marked as H on the weather map. Now we shall move ahead, and this is like basically something that we did. Now we shall move ahead and we studied about the pressure areas. Now we shall move ahead and study about the pressure belts. Do you want to study about these pressure belts? No, we shall not be studying about these pressure belts. But I thought it'd be nice for you guys to witness this. Anyways, pressure belts. What are pressure belts? Those are pressure belts, but we have to study these pressure belts. No one is asking you examination mein what kind of pressure belts are used to lose weight and all of that. Okay, pressure belts. So pressure belts are areas on Earth characterized by a relatively consistent pattern of atmospheric pressure. So pressure belts are areas of Earth. So these are again areas on Earth which are characterized by relatively consistent. So it's like a relative consistent. It's not like it's always the same, this pattern is observed. No, it's consistent relatively. So like accordingly, like they move to one with respect to one to the other. These belts are associated with global circulation patterns and play a significant role in shaping weather patterns and climate zones. Okay, understood. Here are the main pressure belts. First, there are 4 kinds of main pressure belts. You can see this distribution over here, and you can see there are actually 1, 2, 3, 4, 5, 6. No, 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 4, 5, 6, 7. 7 in number. It begins from the south, from polar high to subpolar low, to subtropical high, to equatorial lows, to subtropical high, to subpolar low, and then to polar high. So that's how it goes above. So we shall study. Now the thing is, subtropical high and subtropical high, north and south almost have the same, they have the same kind of characteristics. So we'll study them bunched together. Equatorial low pressure belt, also known as intertropical convergence zone or ITCZ, extends from 0 to 5 degrees north and south of the equator. This is the equator. Above here 0 to 5 degree is equatorial low. Above below is south is equatorial low as well. So it is caused by intense heating due to vertical rays of the sun. The air expands and rises, creating an area of low pressure. Now if the temperature is more, then what does that mean? It means that the pressure will be low. So if temperature is more sorry, okay, if the temperature is more because there are direct rays of the sun, the air expands and it rises above. Expand, how does the air expand? The particles grow apart from each other and it moves ahead above, and then an area of low pressure is created. So it is also known as doldrums and is characterized by calm conditions without any breeze. Subtropical high pressure belt, located around 35 degree to 25 degree to 35 degree latitude in both hemispheres above and below, results from the subsidence of air from higher altitude. The convergence of winds at higher altitudes leads to the descending air. It is also known as horse latitudes and is associated with calm weather conditions. Subpolar low pressure belt. It is found between 60 to 65 degree latitude, and it is more developed and regular Yes, so subpolar low pressure belt, it is found between 60 to 65 degree latitude in both hemispheres. But the thing is over here, when I mention these latitudes, right, and in the diagram if you observe, they are differently mentioned somewhere. So it's like, this is like an estimation of these regions. It could extend beyond 5 degrees, it could extend beyond 65 degrees as well, it could go to 75 degrees, and there's a shifting observed of these belts as well. So it's not something that's very how concrete in its way, but it is something that is observed there, and hence this characteristic prevails in that region. So, subpolar low pressure belt, more developed and regular in the southern hemisphere. In the northern hemisphere, it is broken due to influence of land masses. It is characterized by low pressure and is associated with stormy and unsettled weather conditions. Polar high pressure belt extends from 60 degree to 90 degree latitude in both the hemispheres, and it persists throughout the year at the poles. It is caused by very low temperatures which lead to sinking air and high pressure. So polar high pressure belt extends from 60 to 90 degree latitude in both the hemispheres, and it persists throughout the year at the poles. It is caused by, even though there's a shifting between like other belts, polar high pressure belt usually only reserves itself to that particular region. It is caused by very low temperatures which lead to sinking air. So, temperature is low, pressure is high, and hence the air sinks. It is influenced by both thermal and dynamic factors. It is more regular in the southern hemisphere due to dominance of water. Let's go ahead. Please remember these things, remember these points in your mind while you're preparing the same. Wind system. Wind is the movement of air from areas of high pressure to areas of low pressure. They can be broadly classified into permanent winds, seasonal winds, and local winds. So, we shall not be going very deep into it, but as you can see this diagram over here, the winds and the pressure zones and pressure belts are very connected in the way that they deal with them. And they're like easterlies, westerlies, tropical easterlies, and polar easterlies. So, we do not go into it right now because that's not something that we should be concerned with. But we basically discuss broadly what these are. Let's go ahead. Permanent winds. Permanent winds are prevailing wind patterns that persist throughout the year. As the name suggests, permanent winds, they prevail throughout the year. The examples include trade winds, westerlies, and polar easterlies. Trade winds blow from subtropical high pressure belts. Subtropical high pressure belts. Let's go here. Subtropical high pressure belts from here. What are we talking about? Trade winds. Subtropical high pressure belts towards equatorial low pressure belts. So they go here. Westerlies blow from subtropical high pressure belts towards the mid latitude subpolar low tropical belts. This is the westerlies. Polar easterlies blow from polar high pressure belts towards the subpolar low pressure belts. So, polar easterlies blow from high pressure belt, polar high pressure belt towards the subpolar low pressure belt. Okay, so with this you need to keep in mind the high and the low thing, right? So, always remember in your mind, winds will blow from high to low. It will not go from low to high. Okay, seasonal winds. Seasonal winds are wind patterns that change with the seasons. Monsoons bring distinct wet and dry seasons due to differential heating between land and sea. In summer, the land heats up faster than the ocean, creating a low pressure area and drawing in moisture from the sea, resulting in heavy rainfall. So what happens during summers is that the land heats up faster than the ocean, of course. Now, if the temperature is high, what do we observe? That the temperature high means low pressure conditions. So it means the ocean is relatively more, what should I say, has a higher pressure. So hence winds blow from oceans to the sea, and hence there's a heavy rainfall observed. In winter, the land cools down and there is a creation of high pressure area, and this results in dry weather conditions. Seasonal winds can have significant impacts on agriculture, water resources, and regional climates. Local wind systems. Sea breezes. Daytime winds that blow from sea towards the land due to differential heating between ocean and land. You can see this over here. Sea breeze blows in the daytime and land breeze blows at night. So land breeze, nighttime winds that blow from the land towards the sea due to differential cooling between the land and ocean, mountain and valley breezes. Daily winds caused by the differential heating and cooling of mountains and valleys. Monsoons are seasonal winds that occur due to differential heating between land and sea, bringing distinct wet and dry seasons. Okay. Measurement of wind direction speed. So over here we have a wind vane, and this right here is a anemometer. Wind vanes are instruments used to determine the direction from which the wind is blowing. They typically consist of a horizontal arm or vane that is free to rotate and point to the wind. See this one. The vane is marked with directional indicators. You can see the indicators as well. Anemometer, now why are wind vanes used? They are used to determine the direction from which the wind is blowing. So it tells you the direction from which the wind is blowing. Anemometers are devices designed to measure the speed or velocity of the wind. The measurement which records wind, speed and direction, sunshine and precipitation is called a meteorograph. So there are three things. One is a meteorograph, another is an anemometer, and then there's a wind vane. Rainfall. So rainfall is the deposition of moisture from the atmosphere in the form of water droplets or ice crystals falling to the earth's surface. It is a crucial component of Earth's water cycle and plays a vital role in sustaining ecosystems, agriculture and human activities. So rainfall is basically a form of precipitation that is necessary for sustaining ecosystems, and it's for agriculture and for human activities. What is convectional rainfall? Convectional rainfall occurs in warm tropical regions with intense solar heating. So air near the surface, again, it's the whole concept of temperature and pressure. Air near the surface gets heated, rises, cools rapidly, leading to condensation and formation of cumulonimbus clouds. Cumulonimbus clouds are formed in convectional rainfall. Heavy showers or thunderstorms result from the upward movement of warm, moist air and the subsequent release of precipitation. So, because of this, the upward movement of warm, moist air and release of precipitation, heavy showers and thunderstorms take place. Next is orographic rainfall. Occurs when moist air is forced to rise over elevated landforms such as mountains. So while a convectional rainfall takes place in warm tropical regions, orographic rainfall usually takes place in mountainous regions, or where air is forced to rise over elevated landforms. What are other elevated landforms? The plateaus, but over here, since mountains are mentioned, it's relatively more prevalent in that region. As the air ascends, it cools and condenses, forming clouds and producing rainfall on the windward side of the mountains. The leeward side of the mountains experiences a rain shadow effect where the descending air becomes drier, resulting in arid conditions. So there are two sides, there's windward and there's leeward. Leeward is the other side of windward. So it so happens is that air ascends and it cools and condenses and it forms clouds, and on windward side you can see rainfall, you can witness rainfall, you can observe rainfall, but on the leeward side dry and arid conditions prevail. And with this we end this topic. Amazing. Now we shall go ahead with the Indian geography. Now Indian geography basically talks about the physical divisions that we have, and in the Indian subcontinent, which everyone is basically aware about. It's something that we have studied for a long amount of time. It's the northern mountains, the northern mountain range, then there's the Indo-Gangetic plateau, then there is the peninsular plateau, Indo-Gangetic plain, then there's the peninsular plateau, then there are the coastal plains, and then there are the islands. So basically this is what we shall study in very little detail, because all of us, I am expecting all of us know enough about it, but before that there are certain facts about the country that need to be kept in mind. So, location. India is located in South Asia and is the 7th largest country in the world by land area. Borders. India shares its borders with several countries. Pakistan to the northwest. Now, you see over here, Pakistan to the northwest. This is, let's go back to the PPT. This is north, east, west and south. So northwest, let's say this is India. Here we have Pakistan, China and Nepal here. China here, Nepal here. Bhutan to the northeast. Bhutan northeast. Bhutan here. Bangladesh and Myanmar to the east. So Bangladesh and Myanmar are over here. Coastline. India has a long coastline of approximately 7516 kilometers, which is 4671 miles, bordered by the Arabian Sea to the west, the Bay of Bengal to the east, and the Indian Ocean to the south. So we have the Arabian Sea, we have the Bay of Bengal, and we have the Indian Ocean. Now let's go ahead and dive into it. Physical divisions in the country. The northern mountain ranges. It runs as three parallel ranges. The first one is Greater Himalayas and Himadri, which boasts the world's largest, as well as like India's and world's largest highest peaks. Okay, the middle Himalayas or Himachal, the southern Himalayas or the Shivalik. So it's like follows like this: Greater Himalayas, Middle Himalayas and Southern Himalayas. It stretches over 2,400 kilometers from west to east. The Himalayas include several majestic peaks including Mount Everest, Kanchenjunga and Nanga Prabhat. The range acts as a natural barrier separating the Indian continent from Central Asia and providing a source of perennial rivers. Indo-Gangetic Plain. Located to the south of Himalayas, the Indo-Gangetic Plain is one of the most fertile and densely populated regions in the world. It is formed by the alluvial deposits of Indus, Ganges and Brahmaputra rivers. So now Indo-Gangetic Plain is most fertile and densely populated regions. Why? Because like a lot of rivers flow down here and they deposit their sediments and we get alluvial soil. It is formed by alluvial deposits of Indus, Ganges and Brahmaputra rivers. This plain is characterized by rich agricultural lands and is known as the breadbasket of India, as in this is the region which provides food to most of the country. Yeah. Major cities such as Delhi, Kolkata and Lahore are situated. Extremely sorry. It's wrong information. It's the part of UP, Haryana, parts of Punjab, which come under Indo-Gangetic Plain. Peninsular Plateau. The Peninsular Plateau is a triangular shaped plateau located in the southern part of the Indian subcontinent. It is bordered by Western Ghats in the west and the Eastern Ghats in the east. The plateau consists of rocky terrain, plateaus, hills and few mountain ranges including the Aravalli Range and the Satpura Range. The Deccan Plateau, a significant part of the Peninsular Plateau, is known for its black soil and extensive agriculture. So what is the Peninsular Plateau famous for? It is famous for black soil and its extensive agriculture. So carrying this ahead, we have the next physical division of the Indian subcontinent, that is the coastal plains. They lie along the eastern and western sides of the Indian subcontinent. So there's a triangular area, right? This peninsular region. What is a peninsular region? Which is covered by water on three sides. So that is here, here and here. And then we have this region, the western and the eastern sides of the Indian subcontinent. They are narrow coastal plains. The eastern coastal plains extend from West Bengal to the southernmost point of Kanyakumari, and the western coastal plain extend from run of Kutch in Gujarat to the southernmost point of Kanyakumari. So the eastern wait just a minute, let's go back and we shall do this a little illustratively. Okay, so there, just drawing it for our understanding, and it's like, you know, something like this. Let's call that Gujarat, and here we go with West Bengal. So okay, so the eastern coastal plains extend from West Bengal somewhere here to the southernmost point of Kanyakumari till here. The western coastal plain extend from run of Kutch somewhere here again till here. Okay, so these coastal plains are densely populated and contain major cities such as Mumbai, Chennai and Kolkata. Okay, Physical divisions of Indian subcontinent, difference between eastern and western Ghats, as in the same thing, coastal plains. So, the Western Ghats are located in the western part of India, of course, what the name suggests the same, while the Eastern Ghats are located in the eastern part. The Western Ghats are taller and more rugged than the Eastern Ghats. The Western Ghats receive more rainfall than the Eastern Ghats. The Western Ghats are home to endangered species, while the Eastern Ghats have fewer endangered species. The Western Ghats is home to the popular hill stations of Ooty and Munnar, while the Eastern Ghats are home to Araku Valley and Horsley Hills. Okay, with this we come to the next division that we have, and that is the Great Indian Desert, or the Thar Desert as it is known as. So the Thar Desert, also known as the Great Indian Desert, is situated in the northwestern part of the Indian subcontinent. So northwestern, when we say northwestern, we mean, let's do this, north, east, west and south. Northwestern, somewhere here. So this is India. Okay, bad drawing, but yeah, try to understand this. Gujarat, Rajasthan region, somewhere here, okay. It is one of the largest arid regions in the world, covering parts of northwestern India and southeastern Pakistan. So it extends a little bit into Pakistan as well. The Thar Desert is characterized by vast stretches of sand dunes and extreme climatic conditions. So it is observed in deserts as it is that in the day, when it's the day, the temperatures rise quite high, and since it's sand, so it absorbs the heat from the sun quite efficiently for some time, and when it gets cold, like at night, so the temperatures drop drastically and it becomes pretty cold. The islands. The coastline of islands in India is about 1197 km. India has two major groups of islands, the Andaman and Nicobar Islands, and secondly the Lakshadweep Island. Andaman and Nicobar Islands lie in the Bay of Bengal. So remember, Andaman and Nicobar Islands, Bay of Bengal, and consists of about 572 islands or islets. These islands are in Arabian Sea, and by these islands we mean Lakshadweep. Lakshadweep Islands are in the Arabian Sea, and there are around 36 islands in number, of which Minicoy is the largest one. So in Lakshadweep, we know that there are 36 islands and Minicoy is the largest one. In Andaman and Nicobar Islands, we know that it consists of 572 islands or islets. So with this, we come to an end of this theory lecture, and I hope you paid attention. I hope you made your notes. Again, this was not something that was extraordinarily difficult. Maybe certain parts of atmospheric pressure that you guys need to focus on, the pressure belts that you guys need to focus on, but otherwise physical divisions is something that all of us are pretty much more aware of, since we have studied this for a long amount of time. So this was just like a very short recap of them. You should go more into the details if you have studied it before, which I'm pretty sure you have. So with this, we bring an end to this lecture. Thank you so much for watching, and again, until we meet again.